Welcome viewers. Today we are going to start the first lecture of the computer numerical control of machine tools and processes. My name is E. Rai Chaudhary and I am a professor in the Mechanical Engineering department of IIT Kharagpur. So, first of all, computer numerical control, what does it mean? It means that control of a particular machine tool or a process is achieved by insertion of or use of numbers, symbols, signals, letters, codes, words, instructions. In other words, in short, the communication with the machine in the form of a language. Previously, machine and human interaction used to take place through physical devices like cams, tracers, templates. So, it was not very sophisticated, but now with the advent of numerical control and computer numerical control, a sort of language communication was started with machine tools and processes. So, in what way can this happen? It can happen in the form of input to the machine, data input through numbers, letters, codes. This data can be processed inside the machine through numerical calculations, logic operations, and execution of operations can be carried out through generated signals from the computer or from some control circuit in the form of voltage signals, etc., etc. So, what is the connection between numerical control, computer numerical control, etc.? So, in the beginning what happened was there was no computer to start with and we had numerical control machines in which numbers and alphabets were used in the form of codes to feed information into a machine. And for that, at first these machines were called or they were referred to as numerical control machines. Inside they were primarily consisting of hardwired logic circuitry, and after the advent of computers, data entry became easier through the computer. Wired circuitry, logic circuits, etc., sometimes were replaced by software, and control inside the control loops, the computer also used to participate in order to improve the control characteristics. So, it became known as computer numerical control or simply computer control. What is the area of application of computer control? Do we understand that, say, in mass production, that is high volume production, lots of pieces made in a particular span of time, say 1 lakh pieces in 1 year. So, in mass production, would CNC or computer numerical control be suitable? Here, surprisingly, it is not so. Why? Because mass production finds the application of fixed automation. That means, fixed means machines which are they can only carry out certain operations and nothing else. Special purpose machines. Special purpose machines find wide application in mass production together with automated material handling devices. Why so? This is because in case of mass production, there is not much change in the part design over extended periods of time. There what we find is a huge number of pieces have to be made again and again repeatedly over long periods of time. So, a computer which is primarily meant for flexible communication or changeable communication with machines, it does not find wide application in this particular area. Not much change is there with time. So, we generally go for systems which are exactly dedicated for that particular purpose. Special purpose machines, for example, camshaft grinding machine, it can only grind camshafts and nothing else. So, that is why in mass production CNC is not very suitable. CNC's strong point is it can be changed very easily. Why? Because it is consisting of language instructions, it is consisting of numerical calculations and logic operations inside the machine. These things are not very difficult to change if the requirements change. And why not fixed automation for low volume production? By low volume production I mean small lot and batch production, even piece production. This is because fixed automation has dedicated machines. So, if you dedicate some machines, build them for very small number of pieces, after that part design becomes gets changed to a different part, you have no use for that particular fixed automation, it becomes obsolete. That is why if you have low volume production, you cannot implement fixed automation or dedicated material handling system. In that case, you cannot automate it with fixed automation. In that case, CNC becomes highly applicable, because if you are wanting automation, make programs on the CNC machine which can produce those parts, and when the part changes, part design changes, because it is low volume, small numbers of different jobs one after the other. So, when the part design changes, make a separate program for the next part and start running the machine. Very the costs for changeover will be much less in this case. So, we understand that for low volume production, small lot and batch production, etc., CNC would prove to be highly appropriate. Also, we should not I think I should mention here at this moment that CNC also has the ability to manufacture complex shapes, okay, without part specific tooling. Part specific tooling means, say, form tools. If you want to make a very difficult profile, make a form tool, a conjugate profile, and machine that particular part. So, you incur a lot of costs for the tooling. In CNC, it is not the tool shape that produces the conjugate shape on the part, but the tool movements properly controlled by the computer can produce very complex shapes. This is an added ability of the CNC machine. Let us see how the control is achieved in case of CNC. There you can find I have drawn a monitor to represent the computer, and from the computer there is some signal which can directly control a motor. But is this a CNC machine? It is not. I have intentionally drawn a conventionally controlled lathe, okay, operator run lathe, on which you will see some equipment like speed gearbox, feed gearbox, carriage nut, etc. It is not a CNC machine. So, in order to achieve control over a machine, first of all a computer has to be there, it has to be interfaced with the machine, and the conventional machine tool architecture has to be changed. So, we will find some changes taking place in this particular architecture, and apart from that there should be the addition or incorporation of some devices which can control the motion and the extent of motion, I mean rate of motion and the extent of motion. And also we have to ultimately write a program on the computer and execute it, so that it develops proper signals to the motor and other devices of the machine in order to control it. This is how computer control is achieved. So, comes the question naturally, what is a CNC program? A CNC program is a sequence of commands, just like we give a sequence of commands to someone to carry out some operation. It is just a sequence of commands, it is written in a suitable language, and it is meant for controlling the operations of a machine. When executed, it makes a machine tool carry out some motions and auxiliary operations. Generally by motions I have meant here, say a fast motion to approach a particular point, and then say starting a linear cut at a controlled rate, then taking circular cuts either clockwise or counterclockwise at a definite feed rate, and also there can be auxiliary operations for tool changing, for for changing a job and bringing in another palette containing another blank, like that. And this way, when a computer program is executed, it will ultimately lead to a part being successfully produced from a blank. And CNC program ultimately does not necessarily mean that it is only for controlling the operations of a machine tool, but it can be employed for controlling other general purpose machines, other general machines as well. This is an example of a typical, some command blocks taken from a CNC machine. What does it show? The first column shows the line number N006, N007, etc. After that, we have a number of codes placed one after the other. What are these codes? For example, G90. G90 means that whenever there is a coordinate system existing, on that coordinate system, we are supposed to refer to the absolute x and y coordinate values of a particular point. So, we have a coordinate system in front of us, and we can see that x and y is written there, and in that x y coordinate space, G00 says G00 means that we are supposed to reach a target coordinate position given by x20, y30. So, it basically means move fast. G00 means rapid traverse to the target point. No velocity is mentioned because generally the machine moves at the highest possible velocity. So, move fast to the point x20, y30. After that, we are supposed to move, then in the next command, we are supposed to move to the point y50. Why is x not mentioned? Because it is not changed. So, x remains the same, and we change the y coordinate to 50 from 30, which means we are now at the point 20, 50, and we have executed a vertical motion. After this vertical motion at 20, 50, after that it is written G01, x100, y100, f200. What does this mean? G01 is a code for linear motion, that means straight line motion at a particular feed rate, that means at a particular rate of motion. The rate of motion is mentioned as f, feed. It is called the feed word. 200 means, if not otherwise defined, 200 millimeters per minute. So, the target point is mentioned as x100, y100. So, we reach the target point 100, 100 from the point 20, 50 at the rate of 200 millimeters per minute. Next line is G02. G02 means circular interpolation clockwise. So, we move from the present position of 100, 100 to the point 140, x 140, okay. And as y is not mentioned, y remains the same, and the radius with which we move is 30 millimeters. Okay. So, we reach this particular point at the same feed defined in the previous line to the point 140, 100 from the point 100, 100 at a radius of, with a circular radius of 30 millimeters in the clockwise direction. Is there any other possibility of reaching this particular point? There is, but unless otherwise mentioned, it will take this particular what do you call it, minor arc. There is a major arc possible also with 30 millimeters clockwise, that is not taken. M30 means end of program. So, this is a typical example of a few command blocks on the CNC machine. Now that we have started discussing on CNC machines, computers were not there throughout the ages, and we did not have NC machines also beyond in the past, say 70 years back or even more than that. So, at that time, how were automatic operations executed on machine tools. This is one example of mechanical automation. It means some sort of clockwork mechanized motions were carried out without the help of computers, without the help of numerical instructions, codes, language, etc. Simply physical devices were used. It means something like, if you want to command someone, you can tell him or her, or you can push him or push her to do that particular task. Physical devices. So, here we see a cam. A cam is a device. In this case, we have shown a disc like cam, which has a profile on its periphery, which deviates from a circle. So, that if it is rotating, it will move anything in connection with it radially outwards. So, here we have something called the follower, which is pressed against the cam with the help of a compression spring, and when the cam moves in a uniform circular motion in a counterclockwise direction, it will tend to push the follower, and then suddenly the follower will fall back when the fall of the cam or drop of the cam along the radius takes place. So, it will push the cutting tool also towards the left side continuously, and then suddenly it will retract. So, this is the scheme of motion of the cutting tool, which has been planned with the help of this particular cam. Is there a computer controlling it? No. Is there automatic motion getting repeated again and again and again? Yes. What is the purpose of this motion? Maybe it is moving forward, parting some job, and then again retracting very fast, the job is getting fed again. So, this continues unless something wears out, either the tool wears out or power goes off or the cam undergoes wear and tear. So, this is a perfect example of an automatic machine by mechanical controls. Okay. So, this is also existing without computers, automation, and there is a question given, that is, what should be the profile of the cam in order that we will have constant forward feed of the cutting tool. What should be the profile of the cam? The answer is Archimedean spiral. You can try this out yourselves. So, coming back to computer control machines now, we have seen the example of mechanical controls being achieved in case of automation. So, how do computer control machines carry out this particular control? In computer control machines, instead of devices like cams, etc., there are programmed instructions which go inside the machine and develop, when they are executed, these programmed instructions, they develop digital signals which might be ultimately rotating motors at a definite rate, and this leads to achieving a definite extent of motion and achieving a particular ratio of the axis velocities, okay. And also it results in the attainment of a programmed feed velocity along the cutter path. Why are we so much concerned about the programmed ratio of axis velocities? Because that is ultimately the particular parameter which determines the profile taken, determines the path taken by the tool, which ultimately defines the profile of the part being machined. Here there are no physical devices, but the path of the tool defines the profile of the job. So, we have been talking about digital signals, binary logic, logic gates, digital circuitry quite a lot. What do we exactly mean? Many of you might be conversant with digital circuitry, digital logic. In case you do not have an introduction, formal introduction to this particular subject, we will be taking up in the next lecture some aspects of digital logic, and hopefully you will be able to follow the later parts of the other lectures, which involve some discussions on logic circuitry. What we have shown here is this, that digital circuitry will be employed in many aspects of CNC control, like data input, data storage, processing, interpolation, motion execution, etc. In the figure we have shown two typical logic gates, and how do we read them? Like A and B, if there are two inputs which can only take up two values, like say high value and low value, AND gate is a gate which controls the relation of A and B in such a way that C is going to get a high value only if both A and B are simultaneously high. This is called AND gate. That means you and say x and y, if both are high, then only z is high, z is the output. In the same way, OR gate is a little more lenient. It says that if A is high and B is high, or any one of them is high, then the output is high. In three cases, A and B both are high, A is high, B is high. In these three cases, the output will be high. When both are low, then the output will be low. So, we will have some more discussions on logic gates. They are not exactly mathematical operations, but logic operations. Now that we are we have gone into the discussions of CNC machines. Let us see what is the architecture of the control unit, that is what is there inside which does all the control. The control unit is frequently referred to as the machine control unit, which contains two different modules. One is the data processing unit and another is the control loops unit. What does the data processing unit do? It is concerned with data entry, data processing, that means all sorts of calculations involving the data, and also interpolation. Interpolation means that you are instructing the machine to move on a say circular path or a linear path from one point to another, but you are not instructing it about what sorts of velocities and positions it is supposed to attain in between. So, somebody has to do the calculation, and there is a device called interpolator inside the data processing unit, which does all these calculations and finds out the intermediate positions and velocities of the tool, okay, in order to cover the intermediate path between two programmed points. The control loops unit, it contains all the devices achieved for achieving required motion along an axis. For example, it might involve the actual motor or the prime mover, the lead screw nut, the gearbox. All these things are together referred to as the control loops unit. And now that we are talking of, we had referred to the modifications of the conventional machine tool in order to achieve CNC machining. So, let us have a quick look at that. What are these? For example, the machine has to be more robust and rigid for the same power level. Why? Because deflections etc. Should be less, so that errors are less. Are deflections there in other machines? There is, but there are physical devices to ensure that the movements etc. are exactly carried out. Here we are depending upon, in CNC we are depending upon the accuracy of the movements etc. in order to achieve a particular accuracy on the job. Backlash elimination has to be there. Motions here have to be completely free of backlash, and for that a number of devices need to be incorporated. For example, the recirculating ball screw nut mechanism. Gearboxes which establish definite ratios of motion between axes of motion in a particular machine. These gearboxes limit the ratios of between axis speeds, and therefore, they are generally eliminated. But gearboxes for attainment of a particular range of speeds, that has to be there. Feedback is sometimes necessary where the prime mover is not capable of carrying out exact motions as required by the program, and generally from complex or compound chains or structures, we generally go for simple kinematic chains, which means we will be discussing these things in more detail, and motors with lower time constants are preferred, which have faster response. Interpolators are necessary in case of continuous control, and we need to have machines which have a more where overshoots and sluggish response can be avoided. That means the dynamic constants of the machine have to be so designed so that overshoots are less and sluggish response is avoided, etc. So, in this machine, if we want to implement computer control, we can see that there is a chain moving from the top up to the spindle, and there is also power flowing this way. So, that the same motor through gearboxes is controlling two motions. This has to be removed and a separate motor has to be put for the feed motion. So, one motor for the feed motion, one motor for the speed motion, and yet another motor would be required for the cross feed, one for cross feed, one for longitudinal feed. Okay. For example, here we see a milling machine in which we have three motions x, y and z, and there is a motor which is also providing the cutting speed. Instead of this, on the CNC machine we will find one motor for x, one motor for y, one motor for z, and also a separate motor for the rotation of the cutter. So, finally, let us look at the advantages of CNC machines. It is more flexible, it is possible to incorporate automation in low level production, we have the ability to cut complex profiles, and in many applications we can attain higher productivity and accuracy. The disadvantage is that the initial investment is very high and required skill level of machinist, operator, etc., is high. There is one practice question. Main advantage of CNC machining over fixed automation is flexibility, accuracy, speed, none of the others. The answer is flexibility. Very much.